Hello everyone, welcome to the channel Data Science with Harshit. So in this particular video, I want to talk about the essence of machine learning. It's in fact a tutorial where we learn how we can, train a linear regression model right from the scratch using TensorFlow. And I was actually fiddling around with the automatic differentiation feature of TensorFlow, and I was trying to learn how to compute gradients and how can we actually, how would back propagation work. So just was trying to build an intuition, and I came up with this tutorial at a random point where I decided that let's just create something very interesting. So this is a very interesting concept where you'll learn a little bit about linear regression. I suggest that you go through some in-depth post and there's some mathematics involved, partial derivatives as well. So that is used because you want to minimize the loss. So we talk about the main components, the loss, the optimizer, and how you can perform partial derivatives using gradient tape from TensorFlow. So we only cover the applied part of it, the coding part of it. If you want to dive into the math of things, you might want to go to Andrew Ng's videos or someone else. So I have linked all the resources below, so you can check them out as well. Let's get down to business. Let's start coding this simple linear regression model, and we'll train it from scratch without using anything else except TensorFlow. So what we are trying to do is we are going to learn the essence of machine learning. So we're going to do that by learning how we generally train a machine learning model. And in this case, we have taken an example of a linear regression model. So it's going to be very simple. We are going to do it from the scratch, and we'll see how TensorFlow chips into this whole paradigm, this whole system. So the important concepts that one should learn is, you should know what is linear regression. And if you do not, I'll give you a brief understanding, but you should definitely check out some in-depth posts. Do Google it. There are plenty of resources on linear regression. Then second point is, how does a gradient descent work? That is something that you should kind of have an understanding, and I'll tell you, how gradient descent kind of works. Just briefly again, I will tell you, I have linked all the resources below where you can learn gradient descent from. And then lastly, we are going to understand how TensorFlow library can be used in order to compute those gradients, and we'll talk about automatic differentiation, which is basically used in all sorts of neural networks that we see these days. So let's see what we have. So let's say we have a bunch of data points, all right, just like the blue points over here, and we are trying to fit a line to this data set. And based on, so basically a single line, has an equation, a general equation of y equals mx plus c. Now, whenever you are training a linear regression model, what is generally happening is the model is trying to learn the value of m and c, because y and x you have provided, but m and c decides what would be, m decides the slope, and c is basically the y-intercept, where the line cuts your y-axis when the value of x is 0. So basically what we are trying to do in a linear regression model is we are trying to get to the best possible values of m and c, where our model would converge and we'll reach the best fit line. So for example, here, let's say this is the first line, which is y equals mx plus c. Then the model learns and it gets to a better stage, and then it kind of tilts again. You see, this is a better fit, and then this is the final line for this particular data set. So this is basically what is actually happening across different sorts of epochs or different training iterations. So at last it kind of learns that this is where the best possible values of m and c, and how do you do that? Let's talk about that. So the main components of any simple machine learning model, like there are different types and there are different learning methods as well, but I'm simply talking about the traditional, the loss and optimization methods. So first of all, you need data to train your model. So you must have data sets. So that's fine. Then the second step or the second component is the model itself, which is basically any model that you're trying to learn is some sort of an equation. So if you have a lot of features, then a lot of values x1, x2, x3 you'd be providing, and it will compute the result based on that equation, based on that model, and it'll give you the value of y, which can be a real value, it could be a discrete value. So and then once you've got the y value, you have to check, all right, what is the difference between your learned value, that is the predicted value, and the actual ground truth, which is the real value. So this is, we are talking about the training data set. So the loss function basically helps you get the errors in your predictions, and based on how big the error is, you try and optimize your loss function, you try to minimize it. And how do you minimize it? Let's see. So for, let's say if we are talking about linear regression, so our goal is to learn the value of MNC, that's clear. Loss function, we are going to use mean squared error. So there can be, you could have used mean absolute error as well, but we are using mean squared error as the loss function. And here is the equation as well. So y hat is the predicted value, yi is the normal y is the basically the ground truth, and this is the system for this is the equation for your mean squared error. You square the value of the sum and you divide it by the number of values, that is your mean squared error. Now this is basically kind of a convex function, and in order to minimize, so our basically target here is to minimize this loss function, and we'll do it again and again and again until we get to a point where we get the best possible values for MNC. Now this loss function is basically written in terms of M and C. So every time we actually calculate the gradient and we try and find out, okay, can we like move further ahead, and if we can, based on how big of a step you want to take, that is being dictated by your learning rate. So then you move on and you find out the best, basically you find out the bottom or the minimum of your loss function. So we're going to use the gradient descent so to minimize this loss function, and for gradient descent, so this is what the function, our loss function would kind of look like for this loss function, mean squared error. So here what we are doing is, this is on the y-axis you have the loss, and on the x-axis, let's say you write it in the form of M and C or some sort of a weight. Okay, so you can also call it with that what is the weight. So starting point, we basically start off from any random value, so we start off from there, and then based on how big of a step you want to take, that is actually when you define your learning rate, that is how big of a step you want to take, and it should be somewhere in the range of 0.01 or 0.001, because you don't want to like you don't want to keep it too big, because otherwise there can be a chance that you might miss the minimum, or you cannot keep it like too small, otherwise the training would be very slow, it would move very slowly. So what we are going to do here is we need to compute partial derivative. So equation of the loss function would be with respect to your MNC, with respect to the weights that we have to learn. So we would be using partial derivatives. We'll have to compute the partial derivative of this loss function with respect to each of those values, MNC. If you want to practice the math, you can do this manually in order to build a better understanding, and you can watch Andrew Ng's videos for that. If you want to learn more, like but here we are going to use TensorFlow's gradient tape. So TensorFlow provides us all the features for automatic differentiation that we are going to use, and I'll just show you how. So further, we'll be writing a training loop where we'll define, okay, how many epochs you want to train it for, the number of times you want to run that loop, and we'll define the learning rate, which is the step size of our gradient descent. We'll keep updating the weights, that is the values of m and c, and then we'll keep on calculating the loss as well. So at every point you'll get the loss, you'll get basically the updated values of m and c, and we'll see how the model actually tries to learn and converge, and we keep doing that until we get to a best fit line. So let's quickly dive into the code. So for the code, I am using Google Collaboratory Notebook. I've created a new notebook over here. So let's quickly rename it Computing Gradient Descent. So this part is done. Now, first of all, let's quickly import all the required libraries. So we are using import TensorFlow as TF. That's the main library for this particular tutorial over here, and if we would need any other library, we'll import it based on our needs, so that's fine. The first step is to basically create our data set. So let's quickly create the data set, and for what we are doing is we are let me just quickly define the learning objective. So and what all we have to do. So here what we are doing is we are basically writing low level code, all right, to implement linear regression using TF. All right, and what we need to do is we are actually also learning how to compute gradients using gradient tape, and lastly learn the model. So our model is basically of the form. So the equation that we are trying to model is equation. So let's quickly check this. So this is our model, basically y equals 5x plus 8. So according to this, we'll create some toy data set. We are not using any real world data set. We will create our own data set. So for data creation, we again are going to use TensorFlow tf dot constant. So let's quickly do that itself. Create data. Okay, so how are we creating the data set? So we need x and y. So let's quickly create x. So x is basically our tf dot constant. So you can create tensors using constant, or you can use the variable. So this will, I'll just show you how this creates a tensor. So tf dot constant, and you need to provide the range of values. So let's define range equals 10 and keep the data type to float. D type equals float 32. All right, and then we are going to create y. All right, so y is going to be 5 star x plus c. So that would be our y. So yeah, so after creating this, let's print what is in our x and y. So x is going to be this, and y is going to be this. So once we run this, c is not okay, 5x plus 8, sorry, I'm still running in the y equals mx plus c mode. So yeah, x, we have got x. So x is basically, these are both tensors. So if you like check x this way, this is going to tell you that this is a tensor of shape 10. So basically we have 10 elements, 1D array. It's an numpy array of data type float 32. So this is basically what we have in our data set. So we have now created the training set. You can also create a testing set. So testing set is again going to be the same way, x underscore test. So you can again use tf dot constant. We are creating a tensor, and this time we keep the range from 10 to 20 and provide the data type, which is float 32. All right, so this is our x test, and again y test is equal to 5 star x underscore test plus 8. So this is our this is basically our testing data set. Now what we are going to do next is we are going to simply create a model. So let's say what would happen, forget about linear regression, what would happen if we predict the mean of the training sample as the prediction for all the values. So in that case, let's say predicting mean, so there's no model, basically we are using that let's just predict the mean as the final answer to all the testing samples. So if you are passing testing data set to our model, we will simply give you the mean as the answer. So predicting mean as the solution. So here what would happen is basically I am going to write a function. So function is basically define, let's say this is our predict function. To this function, if I'll pass the sample data set, and what it will do is it will do y underscore pred. So how many based on the number of samples that you have sent us, all we'll do is we'll provide you the mean. So let's define this mean here. Y underscore mean equals that is based on our training samples. So y dot numpy, TensorFlow is based built on top of numpy, so you have this numpy method as you can see over here in the tensor as well. So y dot numpy, I am getting all the values and then I'm calculating the mean in this way. So based on all the, so in y I have all of these elements, I'm just computing the mean over here and I have stored it in y underscore mean. Here I have, all I will do is based on the number of samples that you send to this predict function, I will simply predict or send you the mean as the solution for each of those samples. So this is our y underscore pred. So this is our predictions, and we'll have to find out what's the error. So for computing the error, so again we write our compute MSC function. So this basically takes the predicted value, or you can say y underscore pred, and the original value, and based on this we will compute all the errors. So errors is going to be y minus y underscore pred, and we'll simply square it. And so this would be basically it's broadcasting that's happening. So each individual element, so there would be element wise subtraction happening over here. So return TensorFlow, we'll have to create mean squared error. So mean we'll have to calculate. For this we are using TensorFlow reduce mean function, and you pass this errors tensor to this, and it'll compute the mean of square. So here we are calculating the squared terms, and here we are calculating the mean. So this is our mean squared error. All right, so this part is done. Now let's compute the loss for our baseline model. So this is basically this is our baseline model. The baseline model is very simple. Basically we haven't done anything. We have simply said that the answer would be the average of our training sample. So here y underscore pred, again we pass predict, and let's just run this on our test samples. So we'll get the y predictions, and loss we'll have to compute. So compute underscore MSC, and to this we need to pass the predictions and the original values, the testing y underscore test basically. So if you'll pass this, you'll get the loss. It'll compute the loss for you for the testing samples, and you can check the loss. So loss is basically 2706. So loss dot numpy you can do, and it'll give you the value exactly. So this is our loss. So you've kind of got the gist. We have predicted, we have computed the loss. Now comes to the linear model. So let's try to code the linear model. All right, linear regression model. So here we'll be doing a bunch of things. All right, so first of all, what we'll have to do is, so we are trying to predict the values of m and c, all right, and we'll need to compute partial derivatives, and these values would be in the form of, the equation will be written in the form of m and c. So the function that we'll have to derive using the gradient tape, it should be written in the form of m and c. So here we'll have to like change our compute MSC function. So compute underscore MSC for, let's say, linear model. So to this compute MSC function, what we'll do is we'll pass x, okay, then we'll pass y as well, we'll pass m, and we'll pass c. So this is basically what would happen. These are basically all the components of our linear regression model. And what would happen is we'll first calculate the predictions. So y underscore pred, and we'll get it by m star x plus c, whatever we have passed to this model. Sorry, this is sometimes the IntelliSense just plays around with you. So here again, the next step, compute MSC, we are calculating the error. So that would be, again, that would be simple. So y underscore pred, you can simply use this line over here. So this is, again, this is fine, y minus y underscore pred, and you square it, and then you return the tf dot reduce underscore mean, mean of the errors. Okay, so this is our compute MSC function for our linear model. So this is pretty simple. Now comes the important part. This is the loss function that we have to calculate the derivative of, and we have computed it in the form of m and c. So m and c we will keep learning, and we'll have to initialize it, but we'll do that in the training loop in just a bit. So here, what we'll do next is we'll have to write the compute gradient function. We have to minimize this function. So let's say to minimize the above loss function, we have to compute the partial derivative with respect to m and c. So with respect to m and c is the part where we have defined the compute MSC function, and this is all going to be done very easily. So let's define our compute gradient function. So this is the function that we write, and again here as well, this is the main function that we'll be calling x, y, m, and c. All right, and to this function, what we'll do is we'll use with. So this is the syntax for gradient tape. With gradient tape, you just tf dot gradient tape, as you can call it simply tape. So this is basically the syntax that we have on the TensorFlow documentation as well. And if you want to see, like, you can do let's say gradient tape. Yeah, so you can learn more about automatic differentiation and gradient tape, how it works. So they've given a bunch of examples over here. You can deep dive into these as well. So alright, so how they are calculating the gradient tape, and it's used in a lot of other functions and values as well. TensorFlow is more of a mathematical library as compared to a machine learning library that we have a notion of. So again, with tf.gradient tape as tape, that part is done. Now you have to wrap this loss function that you have around this, on this tape. So loss equals, you have to compute the loss within this tape. So compute MSC underscore for linear model, and you pass x comma y comma m comma c. So we have passed all the parameters, the required parameters, to this compute the loss function, and all you need to do is simply return tape dot gradient, all right, and the loss that you have calculated along with the parameters on which you have to, with respect to which you have to compute the derivative. So here it's going to be m and c. So this is as simple as that. It'll compute the derivative, will get you the dm and dc, which is the derivative with respect to m and derivative with respect to c. So how are we going to use these? So let's quickly define the functions. So let's say we have computed some random values for m and c. So let's start off by 0.0, and similarly for c as well. So m and c we have defined. So dm is so we'll calculate the loss with respect to dm, and derivative of loss with respect to c. So here we'll compute underscore gradient, and we'll pass x comma y comma m comma c. I'm just running it for once. We'll define the training loop now, so that is fine. And then we'll just simply print, okay, dm, or you can say gradient with respect to m so this is going to be dl underscore dm, and the next one is going to be dl respect to c. So let's print these. So here you see this is a gradient with respect to m, and this is all happening here. So we have already defined x, y, m and c. M and c we didn't know. We have randomly initialized the values of m and c. So this is you can say random initialization of m and c. All right, so we have used the variable TensorFlow variable tensor here. So these two are basically scalar tensors, you can say rank 0 tensors, and I have computed the gradient. So this is the initial gradient. This is the first time. Now I need to, in order to find the best possible value of m and c, we need to minimize this loss. We have to keep minimizing until we get to a stage where we are convinced with the values of m and c that we get. So what we do here is we simply have to define our training loop. So this is the part where we define our training loop. So quickly, all we need to do is we need to first of all define some steps. So the number of steps is going to be, let's say we train it for 1000 steps, okay, and we also define our learning rate. Let's call it LR, which is, let's say 0.01, okay, and then for our we are kind of, I'm trying to give it as a form of when you train a neural network with the TensorFlow, we'll kind of give it the same message. So message is going to be a simple string. So this is let's say, or you can say epoch, which is going to be your step, and then this is going to be loss, is going to be your loss, and then lastly the values of m and c as well. Let's print those as well. M and c is going to be c, and that's it, \n. Let's add one \n, new line. So again we will do the same. First of all, random initialization of m and c. So that part is done. Training loop, we have initialized the values of m and c. We'll start off from 0.0, okay, and then the next step is going to be defining the loop. So the loop is basically very easy. So for each step in this range of, let's say we start off from 0 and we do steps plus 1. So this is from going from 0 to 1000. So this is easy. And then we compute, first of all we get the dm and dc. So this is simply compute the gradient. So this will calculate the prediction, do all of those steps, and we need to simply pass x, y, m, and c. So it'll compute the gradients, it'll do everything, give you the gradients with respect to m and c. Now you need to update these m and c values based on the gradients that you have got. So how do you update the value? So we use the assign function. So the constant tensor cannot be updated, but the variable tensor, so these are the variable tensor that we have defined, so these can be updated using the assign method, or you can say assign sub method. So here all you need to do is dm the derivative that you have got, the gradient, you multiply it with the learning rate. So here gradient descent is doing its job. All you need to do is that, how quickly I want to train this, what would be the step size of my learning. So that is your learning rate. So you multiply your gradient with your learning rate, and that will be your new m. And similarly, you do this for your c as well, dm, and this is your dc. So after that, all you need to do is simply print. So we are going to print it for, let's say, every 100 iteration. So step 100 equal to 0, and what we are going to do is loss equals let's say compute underscore msc. So we'll compute the loss over here and we'll get the value. So in order to print our loss, m comma c, and then we print the message. So let's quickly try to run this now. We have done everything. All right, this part is not defined. Okay, on x, we'll define it over here and print this message. Okay, learning rate is not defined. Okay, sorry, the learning rate is LR. All right, so okay, so you see epoch 0, 100, 200, 300, 400, and you can see we started off from a loss of 208. Right after the first gradient or the first derivative was calculated, first iteration, after the 100th iteration, we got from 200 to 4, loss of 4.5, and then after that we went to a loss of 1.46, and at epoch number 300 we reached a loss of 0.47, so on and so forth. Up until 1000 we had a loss of 0.0. so this has really converged, and you can check the value of m and c as well. So here you can actually do m dot numpy and c dot numpy as well. So let's quickly run this again. You see the values of 3.5, 5.6, 5. So it has reached 5 quickly, and it has gone on to predict the best possible values of m and c. So our original solution was 5x plus 8, m was 5 and c was 8, and it has basically predicted the right values, 5.00, and this value of c is 7.97. So it's close to 8. So this is basically the magic behind calculating partial derivatives and how you can do that in TensorFlow. So the backend, you can imagine the backend of TensorFlow, how strong it is and how it is computing all such gradients and different other optimization methods that you see in neural networks. So I hope you found this video useful. You must have gotten some idea, some intuition of how gradients are computed, how partial derivative is actually minimizing the loss, and how to define learning rate, how does it speed up your training, how quickly your model converges. So all those kind of things are actually the essence of machine learning, how a supervised learning problem is actually solved. So there's a lot of math that actually runs behind it, and this is the reason I created an applied version of this using TensorFlow, and there'll be a lot more sessions on TensorFlow that I'd be doing, some streaming sessions as well. So yeah, please consider subscribing if you like this one, do not forget to give this a thumbs up. And yeah, I will catch you guys in the next one. Feel free to comment down below, catch hold of me, or message me on any of the platform, Twitter, LinkedIn. I have provided all the links below. So yeah, until next time, keep learning data science and machine learning.